Thank you everyone for joining. As Jared mentioned, my name is Nir Stern. I'm EVP of Product Management at Mend.io. And today I would like to share with you our experience and insights on how to spot and stop security risks from unmanaged AI tools. A little bit about our agenda. So we'll start with reviewing the rise of shadow AI. Then a little bit about what risks are behind shadow AI and why it's important to be aware of this. Then we're going to discuss where traditional application security falls short when it comes to shadow AI, how to mitigate these gaps using 8 practical ways to regain control. Um, we'll share a little bit about Mend AI product and how it can assist with getting back control over these risks. And then we'll have some time for key takeaways and live Q&A. Again, thank you for joining. I hope you will find it interesting. So, starting with what is shadow AI? Shadow AI basically is the usage of either AI tools and models uh, by developers without a formal approval. This could be the usage of even ChatGPT or any other uh, generative AI tool, generative AI code generators like Cursor, Windsurf, Copilot, vibe coding, and so on. This is on one hand. On the other hand, is the usage of AI components that are integrated by developer engineers into the product that goes into production. And the fact that their shadow is based on the invisibility of this usage of tools and capabilities inside the application security and compliance teams and tools. So, in other words, any usage of AI tools and components that are basically invisible to the application security teams. What's fueling shadow AI? Why this becomes more and more urgent? Uh, so, a few areas. First, we see explosion of usage of generative AI tools. Um, I believe all of you are familiar with it. We see this the news. We see those companies grow really fast and also being acquired. Just I think yesterday, Windsurf was acquired, and more and more developers using those AI tools, and more of the code is being generated by them. Uh, Another factor that fuels this is the fact that developers are under pressure to innovate, and in order to do that, they can do it either by using generative AI tools or by using AI to develop their solutions. And we see more and more of this. Next, there is lack of AI governance, which result in the fact that developers are using those mostly with no control. And even when there are some attempts, especially with large organizations, to form some kind of governance, the fast adoption usually bypass those. And we see organizations that practically have very little understanding and visibility to what's going on in their environments. Where do we see shadow AI practically? So few areas. First, as I mentioned, AI generated code, but that's just one piece that actually I'm not going to cover a lot in this presentation. But what's more risky is the fact that we see more and more AI components and technologies embedded into the product that goes into production. And this can be the usage of public LLMs in production. This is basically integration with inference providers, OpenAI, Bedrock, and so on. We see AI agents that are embedded and running in production, and those AI agents can do multiple things. They can interact with the customers, they can interact with other agents, they can generate code dynamically, they can perform actions, and so forth. And we see a lot of usage of fine-tuned models and RAGs with sensitive data that are being part of this agents ecosystem. And again, the fact that the agents and the models behave autonomously and a lot of times in an unpredicted way and have access to this sensitive data, all of that put a lot of risks on the usage of them. So if we move into why shadow AI is risky, various reasons. I'll try to focus on the main point. So first, as mentioned, currently there is no audit trail or approval process for using them. And this results to basically a situation where in most cases, most organizations do not really have good control and visibility on where AI is being used in the organization in general and specifically inside the applications. In Mend, we identified this gap in the industry, this challenge over a year ago. And when we started talking to customers, in the beginning, we had cases, we talked to customers and asked about the usage of AI and the visibility. And about a year ago, some organizations said, we do not have usage of AI, or they said, we have limited, we know exactly where it is. And when we actually ran our system to create the inventory of usage of AI, we saw what we used to call the 10x factor. It almost always was 10 times usage more than what those companies thought they have. Today, we rarely ever see customers say we don't have usage of AI or it's limited. I think almost every organization today recognize and promote the usage of AI, but most organizations today that do not have the proper tools, do not have the visibility and audit trail to actually manage those. Another reason why shadow AI is risky is the fact that it includes hidden risks. It could be vulnerabilities in the models, vulnerabilities in how the interaction with the models is, with system prompts, the data exposure, and so on. And the fact that there is no standardized security testing. So organizations that have built the best application security program, they have very clear policies and very good governance tools in order to enforce those policies. When it comes to the usage of AI, suddenly do not have any control that you used to have on that part because those tools, those approaches were not designed to address the usage of AI, and suddenly they are fully exposed. And the last point is the fact that AI models and on top of them agents and applications by definition comes with unpredicted behavior if they are not being managed properly and being controlled. Also, the behavior of the models may be misaligned with the expected behavior in the policies that the organization has built. I think the best analogy for this behavior of models inside product is as if you have a new employee. Now, most large organizations, especially those that are should comply with different types of regulation, have good understanding of security measurement, they would make sure that those employees, new employees, are very clearly trained about what they should do with the data, what should they do with the application, and so on and so forth. And without the right controls, implementing models and AI components into your application is like putting an employee that did not go under any education or training and then their behavior is really not something that you can predict if it comply or not. And this is, I guess, one of the biggest challenges. Um, just to share how much this is common and the explosion, this is real statistics from our customers about the usage. And as you can see, very long list of different type of AI technologies that are being used. I think it's almost 100% of the customers that are using it, and you can see it's varies very largely. Of course, many of them are using LLM services by OpenAI. Many are using open source models from different repositories like Hugging Face, a lot of usage of AI agents and RAGs, and then a lot of different types of solution inference providers and types of models. But the usage is growing exponentially. Also, if you look at the AI models usage breakdown, again, you can see huge amount of usage of LLM. That's probably the area that grew mostly since OpenAI started with releasing their ChatGPT and every other vendor that followed them. That's probably the biggest change of what we see in the past year or so, and that's why we see around 50% of the customers having some interaction with LLM. We see a lot of usage of embeddings. This means that they are using RAGs. Basically, they incorporate their own data into the models, which again brings a lot of risk because suddenly sensitive data may be exposed to these LLMs that, as I mentioned, are unpredictable. And we see some other types of LLMs. But the point is that compared to what I mentioned earlier, that about a year ago, we could go to a lot of organizations and they would either say, yeah, we have limited usage, or maybe thinking not at all. Today, this is really not the case. And every organization almost have some kind of usage of AI tools and technologies inside their applications. If you look at some common shadow AI implementation patterns, then we can divide them largely into four types. First is the embedding of either closed or open source models within the application code. What this means? So today there is huge amount of models. Some of them are open source that are available at repositories like Hugging Face, which is the largest one by far. I think over 90% of models are hosted there, or closed commercial models by the large providers, and those can be embedded as part of your application in a closed way. This means that your application is running the models closely, but still the behavior is something that if you do not monitor and control could result in things that are violating your security or compliance policies. Next, on top of models, we see, as we just saw, more and more usage of agents, which basically piece of code that is interacting with the models in order to perform actions. Sometimes it could be multiple agents that are connected together, and then we see different type of agent-to-agent protocols. MCP currently, I think, is the most common one, but we see more and more. And this becomes even higher risk because if you have application using a model that's kind of controlled, and maybe you can have good measurements to predict and make sure that it behaves as expected. When you start to have agents that talk to each other and each one of them can impact each other, then the end result is practically something that is unpredictable. And if you do not control the entry point and the response, then you're at a very big risk. The next implementation pattern is, of course, the usage of external API calls to AI services. Inference providers, as we saw, OpenAI is currently the one that we see used the most, but we see more and more of them. Bedrock from Meta Llama, and suddenly we see also new vendors like, for example, DeepSeek, that maybe again you have some concerns in your organization about using them, either from privacy concerns, legal concerns, and so on. And if you do not have at least understanding of the fact that these are being used, of course, you're at a very high risk. And last, we see a lot of integrations of vector databases, retrieval augment generation, RAGs, patterns, and this is basically unlike the generic models that were trained on public data. This is basically to take your own data, a lot of times sensitive data, and have it as part of the data that is available to the model, which brings a lot of concerns about how this data is being accessed, retrieved, and exposed outside. So all of these are the most common implementation patterns of shadow AI, and each of these patterns have different security considerations. I've mentioned some of them, but the biggest issue is the fact that none of them can be addressed, monitored, and secured by the traditional application security tool. They were not designed to detect or evaluate them. And basically, again, if you have the best program for application security, by design, those systems are completely ignoring all of these technologies and the risks that are attached to them. And that's the main challenge with Shadow AI. So far I talked a lot about security risks, but it's important to also take into consideration that this shadow AI comes with a lot of potential compliance violations, which is in many cases as important as the security one. So various compliance related things that needs to be taken into consideration, especially if you're an organization that needs to comply with them. So first, there are more and more regulatory frameworks around AI that evolve. For example, about unauthorized AI usage and the fact that it can create a compliant risk. Governments are now looking to tame this whole wild west of AI development. The EU AI Act is a great example. In the US, there is now also regulation that is being developed, and more will come for sure because governments understand the risk of this new era. Another aspect that is very much similar to the traditional open source compliance challenges, and it's around the licenses. So open source models comes with licenses, and if you took one of these models and this model comes with a license that cannot be used for commercial application, then you're violating it. If you're not aware of the fact that this model is used in your application, nonetheless, what terms of licenses it has, then you're at the same risk that organizations were 13 years ago with open source. Even when using inference providers, all of these comes with terms of services, and you need to make sure that the ways that your developers integrated those services inside the application meets these terms of services, and that those terms of services is something that comply with your internal policies and so on. And last but not least, super critical, data sets or trained models not always align with the organization's objectives or ethical standards. And you may find your organization using models that were either trained or themselves include behavior that do not comply with your policies or the legal obligations This could impact biased behavior, overfitting, and so on. In other words, you can end up with a model that is integrated into the application, and the application suddenly is biased based on gender, ethnicity, and so on. And then you are basically vulnerable to different type of issues, legally, compliance, and so on. In addition to that, of course, there are very specific attack vectors that are related to AI-driven applications. And again, if you're not even aware of the usage, you cannot protect from these specific attacks. And if you are aware of them but do not have the tools to test and assess these risks, then you are vulnerable to them. So some example to specific attacks that could be relevant when using AI-driven application. So the first one is, this is more for conversational AI, prompt injection, jailbreak attacks. So generally speaking, when you have conversational AI application, it is designed to do specific activities. For example, it could be some kind of an conversational AI that is supposed to provide support to your customers. Maybe it should help them to answer questions, maybe to do some actions, but you do not want it to allow them to first do things they're not allowed to do. For example, to get access to data of other customers. You do not want them to get access to things that are irrelevant to your business. It could be things that are not really harm, like asking for a recipe of a cupcake, or things that are much more harmful, like asking for a recipe to create a bomb or things like that. All of these can harm your reputation, to at least, but of course could do things that are much worse. And usually when building those applications, there are different measurements, basic ones, to avoid those cases, but there are different type of techniques to jailbreak those defenses, or to inject a prompt into your conversation and then bypass those measurements. And if you do not have the tools to test and validate that you're protected against those advanced attacks, and then apply the measurements to protect from them, then again, you're completely vulnerable. Another type of attack is backdoors in model serialization. This is very similar to the usage of any third-party software. But again, with models, when you download them, if the developers downloaded something that could be malicious, or maybe there were no malicious instance, but whoever built that model created it in a way that has a backdoor which can execute remote code, then you're in a very big risk. And again, unlike the usage of open source, where you have the tool, SCA, to identify the usage of it and know what are the vulnerabilities and address them, with models, this will be completely invisible. You will not even know that the model is inside your system, nevertheless, that it's vulnerable. So this is a very big risk. Then we have different type of output manipulation and hallucination. Basically, AI models by design can hallucinate. I'm sure many of you on your personal life have experienced it. Generally speaking, AI models, they are trained to provide an answer, whether they have the information or not. And in many cases, you may ask a question, they do not have the answer, and then they will just hallucinate, come up with an answer that is completely not true. When dealing with personal experience, that could be maybe funny or maybe frustrating, but no real damage. But if it's part of your application and you have a customer and they're asking a question, and the question is being responded with hallucination, that's a big problem. Suddenly, your customer is getting misleading information. Um, Also, they could manipulate the output to provide them something that they want that is not desired by you. For example, to get an offer that is not in the price that is the real price. Again, this is usually combined with prompt injection or jailbreak, but all of that something that you must be aware of the risks to test it, and if you're exposed to test to mitigate it. And last, uh, different type of data poisoning. Again, models are being trained by data. Many times, it's not one-time training; it's an ongoing, and the training is based on data that is sometimes open. It could be something on the web, Wikipedia, maybe different sites. It could be something as part of your application, for example, based on other chats, maybe different type of areas where there are comments. And then there is a risk that someone will poison those data points, will insert comments somewhere or some value in some website that includes prompt injection, for example, or data that will impact the model. And then, uh, again, it can result with undesired model response. So all of these are just, again, examples of the main risks of attacks that you need to be aware of and prepare for. Uh, why traditional application security fails to manage all these risks? So first, it doesn't scan AI models' behavior at all. So no matter what type of application security capabilities you have, SCA, SAST, DAST, and so on, they're all designed to uh, interact with the traditional type of software. They do not know how to interact with models and do not know how to attack them with the new attack vectors. Uh, they are not designed to detect prompt vulnerabilities. Uh, Tools that try to uh, mitigate the risk are missing anything related to models input validation or sanitation. This includes all different type of SaaS solution, for example. There is no models response encoding and filtering. They're missing access control measurements. When it comes to models, they miss fine kind of data issues and no tracking of third-party models at all. So all of these result is mentioned in the fact that with the traditional application security tools, you have very limited to no visibility to the usage of AI, and definitely not giving you the tools to protect against the threats. So, so far I shared all the risks and challenges, but also I wanted to make sure that you get out of this webinar with some insight on what can be done, because there is a lot that can be done already. So we came up with 8 core actions that any organization should start thinking about in order to comply with the risk related to the usage of AI. First, of course, is to create an inventory of all AI components. You don't know what are your risks if you don't know what is being used in the system. And I think that's probably the number one gap and challenge in this whole era. So you need to start with having the capability to have clear visibility of all the AI components that are embedded as part of your application. Once you have that, similar to traditional application security, you need to make sure that you scan those AI components for non-vulnerabilities, especially in models. This is something that is relatively new, but already there are various databases and sources that indicate which models have non-vulnerabilities. So you would want to make sure that not only you have the inventory of all models and AI components you have, but also if any of them are malicious, of course, or have non-vulnerabilities, that you will get that indication. Next, you want to scan for zero-day vulnerabilities in the implementation and instances of the AI components. So how agents are being set up, what system prompts are being used, and so forth. This way, you at least have understanding of what AI components are being used, whether or not they're vulnerable, and where. From there, you can start monitoring the data flow to understand what data can be accessed by these models. If there are any sensitive data, of course, this is much more risky. Start applying policies on what should be done when you identify something, what should be the measurements for different applications and usage. Running generative AI red teaming is the next step. Basically, red teaming is the dynamic testing with the conversational AI applications to make sure that they are not exposed to the various vulnerabilities that I mentioned earlier and more. So to make sure they're not vulnerable for prompt injection, jailbreak, for hallucination, for fake news, for foul language, and many more. Basically, those tools interact with the application as if they were humans, try to get it to to be vulnerable, and if it does, it alerts you, and then you can mitigate that issue. You do want to make sure that you have solution that on its own is powered by AI, so it can be automatically run the test, validate them, and get the results. Doing it manually with the amount of AI usage that I just shared is practically impossible. Once you have all that information, you can start adding different type of measurements to mitigate it. This could be to harden your system prompts, to configure your agents, to add LLM sanitizers, and more. And last, same with every application security practice, you do want to make sure that you educate your developers to work with AI safely inside the applications. So in MEND, as mentioned, about a year ago, we started working on addressing this gap in the industry, this challenge, and we recently have launched our solution to address it, called MEND AI. This solution is evolving really, really fast due to the exponential usage of AI, the exponential innovation around the usage of AI. There are new tools all the time bringing new risks, and we already have large set of capabilities to address the risks I mentioned so far and to apply the 8 steps that I mentioned. So we start with the AI components detection. By scanning your code, the repository, very similar to what's done with application security, we have the tools to detect the usage of the various AI models, agents, MCPs, and RAGs inside your application, and indicate exactly what application and projects use what type of AI component. So you start with the fact that you have visibility and you know which application and projects are using it and who do you need to work with. Next, we have the AI component risk. So the fact that you have usage of AI on its own is not enough. You want to know which ones are at risk. So for that, we get contextual insights on the AI model licensing, security vulnerabilities, and malicious models. So you can address those very clearly. On top of that, we have the tools to create proactive policies and governance where you can define your policies and enforce them. For example, policy that your organization must use only specific inference provider that was approved by your system, or must not use specific inference providers, to define that the organization should not use open source models for Hugging Face without going through approval, and so forth. The automation engine allows, as the scan goes by, to evaluate those policies, and if they are violated, to create a policy violation and perform action. The actions can be sending email, Slack message, create a Jira ticket, and even fail the build. Depends on how you want to create it. Next, we have a tool to evaluate system prompts, whether or not they are vulnerable, and if they are, to suggest how to harden them and make sure that they are protected against the various attack vectors that I mentioned earlier. And last, AI red teaming, where we have over 20 pre-built tests, group of tests. Each group of tests includes many tests, and these red teaming basically dynamically interact with the AI system in order to see whether or not it is vulnerable to specific attacks or not. And of course, you can configure it for your specific business needs, create your own tests, and so on. So this is in a very, very high level what Mend AI is designed to address. Um, some very, very small taste of how it looks like. So this is, for example, our dashboard for inventory and visibility, and customers can see all the different components that are being used, how they're being used. Again, if you have a policy of what components, what insurance providers are allowed and whatnot, you have a very immediate, clear understanding if overall in the organization you comply with your policy or not. Um, you have a whole section around managing red teaming. So detection of which applications require red teaming. This is based on the fact that they're using vulnerable models, or they are part of an application that is accessing sensitive data, or just the fact that they are conversational AI. And then for them, you can identify whether or not the red teaming was set up, what was the result, and what was the uh, overall result of the test, when it was last run, next run, and so on. And then you can have per application all the different factors. Okay, I hope now you see it better. Thanks, Jared. All the different factors can be, I don't know why this actually looks worse. Okay. In addition, we have the generalized red teaming, where you can run the different tests. As I mentioned, the test can be it's dynamic testing to actually interact with the system to see if it's vulnerable for prompt injection, for jailbreak, hallucination, and so forth. And you get all of the findings here. You can get full statistics. You can run it multiple times until you're where you want to be, and periodically, and so forth. And that's it. Okay. I'll wrap with some key takeaways that summarize this presentation, and then I guess we can see if there are any open questions. So first, Shadow AI is most probably already in your code base, as I showed, at least from our set of customers. This is super, super common, and every organization use different type of AI components. The usage of Shadow AI introduced new attack surfaces that you must be aware of and start building a plan to protect. So you need to be AI aware and build an AI aware security as soon as possible. And last, gaining visibility, defining the policy, and automate the measurements to govern those policies is the answer for all these challenges. And that's the end of the presentation. I hope you enjoyed it and it was valuable. If there are any questions, I'm here to answer.
Ooh, sorry, my camera is dark. Yeah, I've got a few questions for you, Nir. The first one I've got is the AI component detection agent-based solution, or does it work like a reverse proxy?
So the detection of the AI components is all done on the left side. So basically, it's not on the runtime, it's based on the code. So we scan your code base. Usually, we integrate with your repository, GitHub, GitLab, any repository you have, or it can be part of your pipeline. And then we scan all the code, and based on that, we identify the various usages of AI components, including agents, MCPs, models, and so forth. Everything I mentioned. So there is no need to actually access your production environment.
All right, and another one is what types of capabilities should AppSec team look for in tools to help them detect and govern the use of unapproved AI tools across the SDLC?
Yeah, so I think this summarizes it pretty well. First, you want to make sure that you have a tool that gives you visibility into the usage of shadow AI. Without getting visibility, without knowing what you have, you cannot protect for it. Then you want to make sure that the solution also provide with the risk assessment related to the usage of these components. Again, one thing that I want to make sure that is clear, we do not see the usage of AI as risky on its own. On the opposite. I think the usage of AI is amazing. It brings new capabilities and functionalities that could never be done in the past. So the fact that there is AI on its own is not risky, but you need to be aware of it. You need to have a tool that actually can share what risks are related to the specific AI models or configuration of the instances with agents and MCPs. I recommend to have solutions that share the risks both from security and compliance, and then to be able to build the policies, to build automation to govern those policies, and also to do the red teaming and the mitigation.
So I think this is a good question. What are some of the capabilities that you have to monitor specific users based on their AD account?
Based on their what, sorry?
The question says AD account.
Active Directory, probably. So we do not monitor the usage of AI tools for employees. Everything I mentioned in this webinar was around the usage of AI tools and components within your application. For that, we detect exactly what application and project the AI components are part of, and based on that, you can directly go to whoever is responsible for that application or project based on the repo and contact them. In terms of usage of AI tools by developers, if that was the question, generally speaking, we're not looking to monitor that. Again, I don't think this is something that can be managed or should be managed. However, we do have tools, I didn't talk about it in this webinar at all, that interact with the code generative AI tools like Cursor, Windsurf, and so on. And using MCP, they interact with them and make sure that the code generated by those tools is secure to start with. But this is a topic, a whole different topic for maybe another webinar.
Of course. So the last question that I've got so far, hopefully people are going to be asking questions here in a moment, but what are some of the red flags or behaviors that typically signal shadow AI, and where is it already present in an organization?
So To be honest, I don't think that without a tool such as the Mend AI that I mentioned, there is a good way to detect the fact that AI components are being used. Um, the only way to do it is to actually have some tool that is part of your environment that scan your code and detect the usage of the different type of AI components, either third-party models, inference providers, usage of RAGs, agents, and so on. And also, very important to correlate them directly to whoever is responsible for that project, so you can easily contact them, especially for large enterprises, so you can easily contact them and make sure that if you have any policies, they comply with it.
All right, looks like we're getting a few more in. How do you recommend approaching cross-functional collaboration when developers are reluctant to disclose unapproved AI use?
Yeah, so that's exactly where tools like MendAI comes into play. Um, so you don't need to um, make sure that developers comply with your guidelines, um, and you actually have the measurement to see what really is being used and whether or not it's being approved and managed by the application security team. I don't think there is any way to force them not to do it without getting the full visibility and then being able to actually see where it's being used. And again, I don't think that this should be prohibited necessarily, but I think the right way to do it is to define the policies. For example, before using AI, you need to go through some approval process. And then once developers see that if they start to implement AI components and you have visibility to that, and they are being contacted, and then they go through the approval, uh, at some point they will comply with the policies. Having said that, I think that like with open source, uh, in the past there were some organizations that tried to um, have control over which model are being used or not and have processes, and that approach very quickly faded away because it was almost impossible. I think very similar behavior will be with models. Assumption should be that developer will use more and more AI technologies, and that you define what is approved, what not, monitor it. If someone is using something that is not approved, then you can contact them or enforce it, and so forth.
All right. Where did that just go? Let's see. Is Mend AI available as on-perm solution, and is there a trial evaluation version?
So it's a SaaS solution. It's not on-prem, although the scanners are on-prem. So the code do not need to go um, to our cloud if that's a concern. Only the insights. And yeah, we have a process of POV. Um, I'm sure as part of the material shared, there will be some um, contact details on who you can contact some of our representatives, and they can instruct you on what needs to be done. Okay.
All right, that's all I have for questions. Unless you have any final remarks or notes that you want to leave with everyone, we can go ahead and close out.
Okay. Yeah, I think I covered everything. So thank you again, everyone, for joining, and thank you, Jared, for hosting this. And enjoy the rest of the day.